Hello students, I am back again. I have promised that I am going to upload video every Sunday and every Thursday, but I am sorry I could not upload my video on this Sunday. Okay, there was some unavoidable circumstances, so I am back here again. This is a second video now. The third video on complex number. This is my third lesson. Okay. So in third lesson also we will continue with the same 1.13, okay, part of AA and AIHL. Okay. So in this we are going to study modulus and argument. So this is also very important part in complex number. So I hope this will be a good session for you. Okay. Let us start then. So what is a modulus? Modulus of a complex number z is equal to a plus bi is the length of the vector AB, the column vector AB, which is the real number modulus of z is equal to square root of a square plus b square. So actually it is length of the vector. Okay. So modulus is nothing but it is the length of the point A comma B from the origin. Okay. Okay. So look here, if you have x-axis and y-axis, I'll show it to you. And suppose you have a complex number here z whose coordinates will be the real part A and the imaginary part B. Then from origin to here we will draw the arrow. Then this OZ will represent modulus of z. Okay. So modulus of z is nothing but the distance of point z, which is representing the complex number z from the origin, and it is always positive wherever it is, in the first quadrant or second quadrant or third quadrant or fourth quadrant, because it is the distance, so it cannot be negative. Sorry, first quadrant, second quadrant, third quadrant and fourth quadrant. Okay then. So if the complex number is a plus bi, then its modulus is given by mod of z, but that mod of z is different from this mod of z. Okay. And it will be square root of a square, the real part, plus b square, the imaginary part. Okay. So notice that modulus of z gives the distance of the point AB from the origin, as I said already. Okay then. So look here, if z is equal to 3 plus 4i is a complex number, then modulus of z according to the definition will be real part square, okay, real part square, plus imaginary part means 4 square, which will be 3 square 9 plus 4 square 16. So 9 plus 16 is 25. So square root of 25, and which will be 5. So 5 is the modulus of the complex number z is equal to 3 plus 4i. So I hope you understood this. Now the second one is z is equal to minus 2 plus 3i. So again, according to the definition, modulus of z will be square root of real part negative 2 square plus imaginary part 3 square, which will be 4 plus 9. Okay. 4 plus 9 will be 13. So square root of 13. Now we can take again another example, third example. If z is equal to 2, or maybe I'll take another one, not 2, 4 plus 2i. Okay. So find modulus of z and conjugate of z. Let us see what will be the difference between the modulus of z and the modulus of the conjugate. So let us first write the modulus of z. Okay, modulus of z, I'll write it down. So z is 4 plus 2i. Now as we have already studied, z conjugate, which can be z bar also, will be 4 minus 2i. So we just change the sign of the imaginary part. Okay. Now modulus of z will be square root of 4 square, the real part is square, plus 2 square, the imaginary part is square. And it will be 4 square 16 plus 2 square 4, the square root of 20, which can be 2 root 5. Okay. Now modulus of the conjugate, let us see what it will be. So square root of 4 square plus of minus 2 square. So 4 square is 16, minus 2 square is 4, which is 20, so is equal to 2 root 5. So therefore modulus of z is same as the modulus of z conjugate, right? So this is one of the property of the modulus, that the modulus of complex number in its modulus and its conjugate, is the same. Let us see now the properties of the modulus function, modulus of complex number. So z conjugate is equal to z, modulus of z conjugate is same as the modulus of z, as we have seen just now. Then modulus of z square is equal to mod z into z conjugate. Modulus of z square is equal to z into z conjugate. This is very important property. We are going to use this property in coming examples. Okay. Then modulus of z1 multiplied by z2 is same as modulus of z1 into modulus of z2. Okay. So it is distributive over multiplication. Similarly, modulus of z1 over z2 is equal to modulus of z1 over modulus of z2. It means it is also distributive over division, provided z2 is not equal to 0. Of course, the denominator should not be equal to 0. Now applying this property again here, modulus of z1 into z2 into z3 into zn, multiplication of the n complex numbers and their modulus is same as modulus of each one of them when multiplied separately. So modulus of z1 multiplied by modulus of z2 multiplied by modulus of z3, so on, multiplied by modulus of zn. And then this we can write, this again we can write as modulus of z to the power n is equal to modulus of z bracket to the power n. So how this can be proved? If z1 is equal to z2 is equal to z3, so on, is equal to zn, all of them are again if z, then z1 into z2 into zn becomes z to the power n, and the right hand side z1 modulus of z1, modulus of z2, modulus of z3 into modulus of zn becomes modulus of z to the power n. So I hope this is clear to you. Note that modulus is distributive over multiplication and division only. It cannot be distributive over addition and subtraction except few cases. Okay, there are always exceptions in mathematics, you already know about it. Okay, now let us solve this example. Okay, so if z1 is 2 plus I and w is minus 1 plus 3i, find, okay, modulus of z, modulus of z conjugate, modulus of z conjugate is square. Okay, so let us start this. A part, modulus of z according to the definition will be square root of 2 square plus 1 square. So it will be 4 plus 1, which will be 5. B part, modulus of z conjugate. So first let us find z conjugate. Z conjugate is, as you already know, in my first lesson I have taught to you That conjugate of a complex number is obtained by changing the sign of imaginary part only. Okay, we don't change the sign of the real part. So it will be 2 minus I, and therefore modulus of z conjugate will be square root of 2 square plus of minus 1 square. Okay, so 2 square 4 plus of minus 1 square 1, which will be square root of 5. So we have just now seen that the modulus of z as well as modulus of z conjugate gives you the same answer. Okay, C property now, C part of this question. Modulus of z conjugate square. So first find the modulus and then square it. So we already have the modulus. Okay, so square root of 5 bracket square, which will be 5. Then D part says z into z conjugate. So z is 2 plus iota or I multiplied by z conjugate is 2 minus iota. So we will multiply 2 with 2, which will be 4. Then 2 with minus I will be minus 2i. Then I with 2 will be plus 2i. And I multiplied with minus I will give you minus I square. Okay, which when simplified will be 4, and then this and this will cancel with each other. I square is minus 1, so minus of minus 1 will be plus 1, and therefore it will be 5. So as we have proved it in the properties, as we have discussed in the properties, z into z conjugate is same as modulus of, look here, z into z conjugate is same as modulus of z square. Look here, second property. Okay, so whenever you see modulus of z square, you can write it as z into z conjugate or vice versa. Okay then, so now E part of this question. E part is modulus of z into w conjugate. So modulus of z into w conjugate, modulus of z into w, not conjugate. So modulus, we will multiply, z means 2 plus I, okay, and w means minus 1 plus 3i. Okay, so first I will multiply them inside and then I will find the conjugate. So 2 multiplied minus 1 is minus 2. 2 multiplied with 3i will be plus 6i. Then I multiplied with minus 1 will be minus I. And I multiplied with 3i will be 3i square. Okay, so it will be minus 2. Okay, plus 6 and minus 1 will be plus 5i. And then I square is minus 1. So minus 1 multiplied with 3 will be minus 3. Okay, so like this you are getting negative 5, 2 and minus 3, negative 5 plus 5 iota. Now according to the definition, this will be square root of minus 5 square plus of 5 square. So square root of 25 plus 25, which will be 50, and 50 can be 5 root 2. Okay. Okay then. Now next one, F part of it. Modulus of z into modulus of w. So modulus of z and modulus of w we have to find together. So, but separate modulus we have to use. So before I start this, let me find modulus of w, okay, because we will be using modulus of w here. So modulus of w means modulus of minus 1 plus 3i, which will be square root of minus 1 square plus 3 square. So 3 square 9 and minus 1 is square 1, 3 square 9 and 1 10. So therefore modulus of z we already have it. Look here, modulus of z is root 5. So root 5 into root 10 will be root 50, which will be 5 root 2. Okay. So you can see that this answer is same as this answer. So this proves again the property of the modulus. Look here. This is the third property here. You can see it. Modulus of z1 multiplied by z2 is equal to modulus of z1 multiplied by modulus of z2. Okay. So this way we are proving the modulus properties also. Now the G part is modulus of z1 over w. First divide and then find the modulus. So modulus of z over w. Okay. So z is 2 plus 3i, 2 plus I, sorry, over w is minus 1 plus 3i. Now I will first multiply by the conjugate of w, because whenever you have denominator a complex number, you should multiply it by its conjugate. Okay, multiply and divide. So what will be its conjugate? Just change the sign of the imaginary part. So I have just changed the sign of the imaginary part. Now my denominator will be a plus b, a minus b. Look here, a plus b, a minus b. So a square minus b square, which will be minus 1 square minus 3i bracket square. And numerator will be, I'll have to multiply both the brackets. So 2 multiplied minus 1 will be minus 2. Then 2 multiplied with minus 3i will be minus 6i. Then I multiplied with minus 1 will be minus I. And last one, I multiplied with minus 3i will be minus 3i square. Okay, so which will be, the denominator is 1 minus 9i square. So I square is minus 1. Okay, so look here, 3i bracket square will be 9i square. So which will be 9 into minus 1. Okay, and then there is one more minus sign, so plus 9. And the numerator will be, so look here, this will be, okay, let me simplify as it is, minus 2. And both of these together will give me minus 7i. And the last one, 3i square minus 3i square will be plus 3i, because I square is minus 1, so minus and minus plus 3. Now this will be in turn 10 in the denominator. In the numerator, minus 2 plus 3 will be 1 minus 7i. Okay, so that will give me, now I will separate the real part and the imaginary part. So modulus of 1 over 10 minus 7 over 10i. And this, according to the definition, will be square root of 1 over 10 square plus of minus 7 over 10 square. So 10 square will come out of the square root, which will be 10. And in the numerator, I will have 1 square 1 plus 7 square 49. So square root of 50 divided by 10. Again it will be 5 root 2 over 10, which will be half root 2. Okay, this is the final answer. Now G we have finished. H part, modulus of z1 divided by modulus of z2. Okay, so in H part, modulus of z divided by modulus of w. Modulus of z means modulus of 2 plus I. Modulus of w means modulus of minus 1 plus 3i. Okay. Now numerator will be square root of 2 square 4 plus 1 square 1. Denominator minus 1 square 1, 3 square 9. So root of 5 divided by root of 10. Now if I bring them together, root of 5 by 10, which will be 1 by 2, and 1 by 2 I can write as 1 over square root of 2. Okay. Now this also can be 1 over square root of 2. Okay. So both the answers are matching. They are equal. Okay. After h, I have I modulus of z square. So first I will square z and then I will find the modulus. Okay. So first let me find I square, z square. So z is 2 plus I, its bracket square, which is going to give me, by a plus b bracket square formula I can expand it. So 4 plus 4i plus I square. So 4 plus 4i, I square is minus 1. So 4 minus 1, 3 plus 4i. Now therefore, modulus of z square will be modulus of 3 plus 4i, which will be square root of 3 square 9, 4 square 16, 25, which is going to be 5. Okay. So like this we get the answer of modulus of z square. Okay. After I, then we have j, modulus of z square, means first find the modulus and square it. Okay. J part of it, modulus of z and then square it. So modulus of 2 plus I and then bracket square I can write. So modulus of 2 plus I is 4 plus 1 bracket square. So square root of 5 bracket square, which will be 5. So this and this are equal. So this proves again the next property of the modulus. Okay, after j, I will find k, modulus of z cube. So for modulus of z cube, first I will find z cube. Okay. So for that, let me find z cube first. So z cube can be z square into z. Z square we have already found in part I. Look here, z square, which is 3 plus 4i. So I will write 3 plus 4i into z, which will be 2 plus I. Now I will multiply out 2 times 3, 6. Then 3 times I is 3i. Then 4i times 2 plus 8i. And 4i multiplied by I will be 4i square. So which is 6 plus 3i and 8i. Look at this. 3 plus 8i will be 11i. And I square again minus 1. So 4 into minus 1 will be minus 4. So 6 minus 4, 2 plus 11i. Okay. 2 plus 11i. Now I will find the conjugate of this. Modulus of this. So modulus of z cube will be modulus of 2 plus 11i, which will be square root of 2 square 4 and 11 square 1 to 1. So which will be square root of 1 to 5. So which will be 5 root 5. Okay. So this is modulus of z cube. Okay. K, then L, modulus of z cube. So first find the modulus of z and then find cube of that. like this. Modulus of z means 2 plus I and then bracket cube. So we already have the modulus of z, which is, look here, modulus of z we already have found, which is square root of 5. So I will write square root of 5 cube. Square root of 5 cube will be 5 root 5. I hope you understood this. Okay. So look here, square root of 5 cube will be square root of 5 square into square root of 5. Square root of 5 square will be 5 root 5. Okay. So like this we have solved all the parts of it. Okay. Now second question is a good question. It says, prove by mathematical induction that modulus of z1 into z2 into z3 into zn is equal to modulus of z1 into modulus of z2 into modulus of z3 and so on modulus of z to the zn. So separate modulus will be multiplied together. Okay. So look at this now. Yeah. So we will prove it by mathematical induction. Prove by mathematical induction. You already have this in your syllabus. What are the steps in mathematical induction? There are always 3 steps. First step is when n is equal to 1, we say that it is true. P of n is true. And then second step also we take for n is equal to k, we say that P of k is true. And using this second property, the second step, we prove that P of k plus 1 is also true. By proving this, we prove that P of n is true for all n integers. Okay. So these are the steps we are going to use. So let us write the proof of this now. First part. Okay. If n is equal to 1, so when we replace n is equal to 1 here, so we will not have so many complex number, only z1 will be here. So left hand side is equal to modulus of z1 and right hand side will also be modulus of z1 because only one part is there, one complex number is there. So therefore P of 1 is true. Okay. So we have proved the first part, the first step. Let me write here first step. Now second step, if P of k is true, actually I should declare it as P of n, isn't it? So let me write here, I will show you one step, one more step, let me write here, because the statement I should write as P of k. A part, let P of k is, it means the statement is modulus of z1 into modulus of z2 into modulus of z3 so on modulus of zn is equal to modulus of z1 into modulus of z2 into modulus of z3 so on modulus of zn for all complex numbers z1, z2, z3, zn where n belongs to z plus. It is a positive integer. Okay. So this is the statement where z1, z2, z3 are complex numbers. So on zn are complex numbers. Yeah. So we have declared that this is the statement P of n, sorry, not P of K. I should write P of N. Okay. Now the first part we already wrote for this. If n is equal to 1, then left hand side is Z1 modulus of Z1, because only this will be there, and right hand side is modulus of Z1, only this part will be there. So therefore it is true for P of 1. Okay. So P of 1 is true. Now if P of K is true, then modulus of Z1 into Z2 into Z3 into so on Zk, okay, is equal to modulus of Z1 into modulus of Z2 into modulus of Z3 so on into modulus of Zk. So we have taken this as true. Okay. So now the third step is we will take it for P of K plus 1. We have to show that P of K plus 1 is also true. So I will take modulus of Z1 into modulus of Z2 into modulus of Z3 so on modulus of Zk, and the last one modulus of Zk plus 1. So from this what I will do, I will take up to modulus of Z separately. So modulus of Z1, modulus of Z2, modulus of Z3 so on modulus of Zk. Sorry, I am not taking the modulus, I am taking only Z1 into Z2 into Z3 into Zk, okay, and Zk plus 1 I am writing separate, okay. So now this is, we will treat this as one part and this is the second part. Now this first part according to this definition is this one, according to the second assumption it will be this one. So therefore I will write this is equal to modulus of Z1, modulus of Z2, modulus of Z3 so on modulus of Zk, okay, and up to modulus of Zk we can separate them, or first let me write it as, because I will tell you why I am doing like this. So I will separate them, modulus of Z1 into modulus of Z2 into modulus of Z3 so on modulus of Zk into modulus of Zk plus 1. Okay. Why I am writing like that? Since modulus of Z1 into Z2 is equal to modulus of Z1 into modulus of Z2. We have this property. So according to that we take the first bracket as one first modulus and Z plus K as the second modulus. Now Z up to Zk we have already proved, this part we have already proved is equal to this. So I will write that modulus of Z1, modulus of Z2, modulus of Z3 so on modulus of Zk into modulus of Zk plus 1. We are writing this by using P of K, because in P of K we have already proved it. So now this has proved the P of K plus 1, isn't it? So therefore P of K plus 1 is true whenever P of K and P of K is true. So therefore P of N is true for all N belongs to Z plus, means positive integers N. So this has been proved by method of mathematical induction. So this completes our proof. So these are the three steps, please remember it. Using mathematical induction they said, So first step is we take n is equal to 1 and show that p of 1 is true. Then second step we assume that p of k is true. So this will be z1, z2, z3, zk modulus is equal to z1 modulus into z2 modulus into z3 modulus into zk modulus. Now third step is we take z1, z2, z3, zk into zk plus 1. Now z1 to zk we separate and zk plus 1 we write it separate. Then by modulus property this can be separated into two parts, okay, like modulus of z1 into z2 is equal to modulus of z1 into modulus of z2, and then this part we write separately with modulus by using p of k. So like that it proves for p of k plus 1. I hope you understood this, okay. Now second part of this question says, hence prove that modulus of z to the power n is equal to modulus of z bracket to the power n, okay. So in B part we have to show that modulus of z to the power n is equal to modulus of z bracket to the power n, okay. So in B part, I will start B part here. Modulus of z1, z2, z3 we already know, z1 into z2 into z3 so on into zn is equal to modulus of z1 into modulus of z2 into modulus of z3 so on into modulus of zn by 1 by a, okay. In a we have already proved it. Now let z1 is equal to z2 is equal to z3 is equal to so on is equal to zn is equal to z, okay. So therefore modulus of z into z into z into z so up to n is equal to modulus of z into modulus of z into modulus of z so on modulus of z n times, okay. We multiply them n times. Now the left hand side will be modulus of z to the power n and the right hand side will be modulus of z bracket to the power n, okay. So therefore we have proved it. Now C part of it says, yeah, I will need more space, no problem. Okay, so third part I am going to prove on the next page. Okay, what is the third part? Hence find, let me copy this third part here. Yeah, this is the third part. So for proving third part, find z to the power 30 for z is equal to 3 by 4 minus I. This we have to prove, okay. So we have to prove that if z is equal to 3 by 4 minus I, then if z is equal to 3 by 4 minus I, then z conjugate will be the conjugate of 3 by 4 minus I, which will be square root of 3 by 4 square plus of minus 1 square. We have already found it many times. So 3 square 9, 4 square 16 plus 1, which will be LCM as 16. So 25 over 16, which will be 5 over 4. Okay. So we found the modulus of z here. Now z to the power 30, that we have to show that we have to find. So now modulus of z to the power 30, we know that we can write it as modulus of z bracket to the power 30 by b. In b part we have already shown this. Now modulus of z we already have, it is 5 by 4. Look here, modulus of z is 5 by 4. So that to the power 30. And I'll find it by calculator. Bracket 5 divided by 4. Okay. Bracket to the power 30. So my answer is 37.5, or sorry, I wrote 5 by, okay, no, sorry. So I have to write 5 divided by 4. I took by mistake something else. Bracket to the power 30 is going to give me, okay, this is approximately 808. I got 807.798. 807.794. So approximately 808 I can write it. Okay. So like this we found the answer. Now next question, question number 3. It says, okay. So question number 3 says, suppose, 1 minute, yeah, here, suppose z is a complex number, find modulus of z if a part 2 into modulus of z plus 4 is equal to modulus of z plus 16. Okay. So let me start the answer of it. A part. So in A part we have 2 into modulus of z plus 4 is equal to modulus of z plus 16. Now what I will do, I will square both sides. On squaring both sides, always remember, whenever you have modulus on both sides, the correct way of removing the modulus is to square both the sides. So 4 into modulus of z plus 4 bracket square is modulus of z plus 16 bracket square. So 4 into modulus of z plus 4 will be z plus 4 into z plus 4 conjugate. I already told you, whenever you have modulus of z square, you can write modulus of z into modulus of z conjugate, or if you have modulus of z square, you can write it z into z conjugate. Okay. So I am using this property. So right hand side also I will write z plus 16 into z plus 16 conjugate. Okay. So I hope this is clear to you. Yeah. So now I will multiply and open it. So 4 z into z will be z square. Okay. Or z into, I will have to write 4 plus z, z plus 4. Okay, so I am simplifying this. First I have to simplify the conjugate. So z conjugate plus 4 will remain 4. Real number doesn't change. So z plus 16, here z conjugate plus 16, the real number doesn't change. Okay, now I will multiply both the brackets and multiply by 4. Okay, so 4, see here, z into z conjugate. So I have multiplied this with this. Now I will multiply this with this. So 4 into 4, 16z. Then I will multiply this with this and by 4. So 16z conjugate plus 4 into 4 now. 16 into 4, 64. Okay. Is equal to, now here also z into z conjugate. z into 16 will be 16z, then 16 into z conjugate will be 16z conjugate, and 16 into 16 256. Now on both the sides the like terms will be cancelled. So 16z will get cancelled with 16z, 16z conjugate will cancel with 16z conjugate. Now what is remaining with us is 4zz conjugate, z into z conjugate, and this will come there. So 4 minus 1, 3z into z conjugate. Okay, and this is equal to, I have 256 and this 64 will go there, so minus 64. So this is going to give me 192. Now dividing by 3, so zz conjugate 192 divided by 3, 3 6 are 18, 3 6 are 3 4s are 12, 64. Now again we are going to use the same property. Z into z conjugate is modulus of z square. Okay, look here, I am using this property again. Okay, so let me write it here. Since z conjugate is equal to modulus of z square, so modulus of z square is 64, which will be 8 square. So therefore modulus of z is equal to 8. As modulus of z is always greater than 0. It cannot be negative. So in the first part we found modulus of z is equal to 8. Now second part of the question is this part. Let me copy it there down. Yeah. So this we have to prove now, B part. So again what I am going to do, I will square both sides. Same property I am going to use. On squaring both sides, we get modulus of z minus 18 bracket square 3 square 9, then modulus of z minus 2 square. Now again I want to use the same property. Look here, this property I want to use again. So this will be z minus 18 into z minus 18 bracket conjugate, okay, is equal to 9 into z minus 2 into z minus 2 bracket conjugate. Why? Since modulus of z square is z into z conjugate. So this property I am using. Now I will multiply it out. So z into z, okay, it will be z square. Yeah. Sorry, before I do that, again I was forgetting about it. First I have to simplify the conjugate. So z minus 18 into z conjugate minus 18, because conjugate is distributive over addition and subtraction. We already know about it. So z minus 2, here z conjugate minus 2. Now I will multiply it out. So z into z conjugate, then z into minus 18 will be minus 18z, then minus 18 into z conjugate is minus 18 z conjugate, and minus 18 into minus 18 will be 18 square, which will be 324. Now this will be 9z into z conjugate, 9 is out here. Then z into minus 2 is minus 2z multiplied by 9, so minus 18z. Then minus 2 into z conjugate is minus 2z conjugate multiplied by 2, minus 18z conjugate, and minus plus 4 multiplied by 9, 36. Okay. Now look here. The like terms on both the sides will get cancelled. So 18z will cancel and minus 18z conjugate will also cancel. Now what I will do, I will take z conjugate to the right hand side. So it will be 8z z conjugate, and on the left hand side I have 324, and this 36 will also come here, so minus 36. Okay, so 324 minus 36, it will give me 288. Okay, is equal to 8 z into z conjugate. Now I'll divide it by 8, so therefore z conjugate is 288 divided by 8. So 71. No, sorry. 8 3s are 24. 8 6 are 48. Okay, so it will be 36. Now again I want to use the property of the modulus of z, which will be modulus of z square is equal to z conjugate. So which will be 36. So therefore modulus of z is 6, as modulus of z is always greater than 0. Here what property I have used? Z into z conjugate is equal to modulus of z square. Okay. So we have shown that the value of modulus of z in the second part is 6. Now C part, I will copy it there. Okay. Now here we know that modulus of z1 over z2 can be modulus of z1 over modulus of z2. So using this property I will separate the numerator and the denominator in the given question. So therefore modulus of z plus 20 upon modulus of z plus 5 is equal to 2. Now I will take this there. So modulus of z plus 20 is equal to 2 into modulus of z plus 5. Now again on squaring both sides. Okay. So on squaring both sides we get modulus of z plus 20 bracket square is equal to 4 into modulus of z plus 5 bracket square. Okay, this 2 has become 4, and here modulus of z plus 20 square, modulus of z plus 5 square. Now modulus of z square is z into z conjugate. So I will write z plus 20 into z plus 20 conjugate is equal to 4 into z plus 5 into z plus 5 conjugate. Okay, because I am using here property, since modulus of z square is z into z conjugate. Okay, so now I will separate the conjugate because it is distributive over addition and subtraction. So z conjugate plus 20, real number doesn't change, 4 z plus 5 into z conjugate plus 5. Okay, so now I will multiply it out. So z conjugate plus 20z plus 20z conjugate. Okay, here now 20 into 20, 400. Okay, now after that I will simplify the right hand side also. So z into z conjugate with 4 z conjugate, then 5z into 4, 20z, then 5z conjugate into 4, 20z conjugate, and 5 into 5, 25 into 400. Okay. Now the like terms on both the sides we can cancel. So 20z, 20z, 20z conjugate, 20z conjugate. Now what is remaining is zz conjugate plus 400 is equal to 4 z into z conjugate plus 100. This way I will take there and that I will bring here. So 400 minus 100, 300. 4 minus 1, 3 z z conjugate. So now again I will bring 3 here and divide. So z z conjugate is 300 over 3, which is 100. Now z into z conjugate can be modulus of z square, which is equal to 10 square, since z into z conjugate is equal to modulus of z square. Okay. So therefore z is equal to 10, as modulus of z is always greater than 0. So this was the third part. So I will add one more page to solve the next part of it. Okay, let me solve all the parts. I wanted to keep one part for you, but I thought I will solve all of them so that you understand it properly. Okay, look at this now. So again, using the property of modulus of z1 over z2, modulus of z1 over z2 can be separated as modulus of z1 over modulus of z2. So using this property, I will split numerator and denominator with the modulus is equal to 5. Now I will take this there. So modulus of z minus 50 is equal to 5 into modulus of z minus 2. Now on squaring both sides, we get modulus of z minus 50 bracket square, 5 square 25, and modulus of z minus 2 square. Okay. Now whenever it is modulus of z square, it can be z into z conjugate. So I will write z minus 50 into z minus 50 bracket conjugate is equal to 25 into z minus 2 and z minus 2 conjugate. Because since modulus of z square is z into z conjugate, this property I am using here. Okay. Now I will separate the conjugate with addition and subtraction. So z conjugate minus 50, real number will not have any conjugate. So z minus 2 and z conjugate minus 2. Now I will multiply out. So z z conjugate minus 50 into z minus 50 z conjugate minus and minus plus 50 square 2500. Okay. Now right hand side, z into z conjugate with 25 will be 25 z z conjugate. Then z into minus 2 with 25 will be minus 50z. Then minus 2z conjugate with 25 will be minus 50z conjugate. And minus and minus plus 4 with 25 will be 100. Now like parts on both the sides can be cancelled. Minus 50z minus 50z minus 50z conjugate minus 50z conjugate. So we are left with zz conjugate plus 2500 is equal to 25 zz conjugate plus 100. So I'll take this there and bring 100 here. So 2500 will become 2400 after subtracting 100, and 25 zz conjugate will become 24 zz conjugate. Now dividing by 24, we get z into z conjugate is equal to 2400 by 24, which will be 100. Okay. Now z conjugate can be modulus of z square, which will be 10 square, since z into z conjugate is equal to modulus of z square. Now from this we get modulus of z is equal to 10, since modulus of z is always greater than 0. So this is the last part. So with this I have completed that question. Now there are few more. This argument part, I think I will take it in the next lesson because I don't want to hurry up. So in the beginning I promised you that I will finish it in 4 lessons, but I think it is going to take more time, so no problem. Argument we will take in the next lesson, okay, which will be on Thursday definitely. Okay, so bye for now. I hope you enjoyed this lesson. Yeah, please like, share and subscribe my YouTube channel. If you want online lessons, please contact me on my email ID, okay, or contact me on my WhatsApp. Okay then, bye.